So first we have our motivation, like why do we care about antiderivatives? And I just put a few scenarios, some applications for it. We've talked about derivatives a lot in terms of like, here's the position function, how do I find velocity? And that was the derivative. But what if instead I know the velocity and I want to know what the location will be at a certain point in time? So instead of knowing the original equation, I know the velocity or the speed, I want to know where you're going to be at a given point in time. If we look at like water leaking out of a tank, okay, so we have a leak in our water tower, and we can look at the water, how fast the water is coming out. Then we need to know the amount that would leak out over a certain period of time. Or if you know the rate, a biologist knows the rate a bacteria population is increasing, you might want to know how many bacteria you would have at a certain point in time. So a lot of times we don't have the original function, we have the rate something is happening, and we have to be able to go backwards and find those original values. That's what's called an antiderivative. Notation-wise, sometimes you'll see capital F for an antiderivative, and it's just the function that came before. So that if I have a function like I said f of x equals 2x, the antiderivative is saying what was my function so that when I did the derivative, I got 2x for my answer. Do you know what that would be? X squared. The antiderivative of 2x to be x squared. All right. What if I asked you for the antiderivative of x squared? So I'm asking, when would my derivative be x squared? So let's think about what happens. When you do the derivative, you subtract 1 from the power. So when I do the antiderivative, I have to add 1. All right, when I do this derivative, my 3 is going to come down, and I don't want it there. So what would I have to put to cancel that 3? Right. So is the derivative of 1/3 x cubed x squared? Okay, let me ask another question. What is the derivative of 1/3 x cubed plus 5? Still x squared. Okay, what if I said the derivative of 1/3 x cubed minus 10? Still x squared. So is there just 1? But what's the only difference? The constant. So the antiderivative is 1/3 x cubed plus a constant. So there are many functions that have a derivative of x squared, but they're all the same except for the constant value that might be on the end. So when we do these antiderivatives, we will always put a plus c on the end to represent the constant. All right, and that's what the next 2 slides are saying as well. So this one just tells us when we do the antiderivative, we have a plus c. This is just the visual. The c is just like an up or down movement, so we can see it's all the same basic function. When you do the derivative, the slope of the tangent line, you're going to get the same thing. The only difference is where was the original at on the graph. All right, so let's find some antiderivatives. If my function is sine x, the antiderivative of sine, what has a derivative of sine? The derivative of cosine is negative sine. So to get a positive sign, I would need a negative cosine x. What else do we have to put? Plus c. B. 1 over x. What has a derivative of 1 over x? Yeah. And that would have to have? And we have to do the natural log. If you wrote it without exponents, x to the negative 1, what happens if you add 1 to that power? It gets x to the 0. So we know that that's not going to work. It's not just the power rule that got us here. So that's the natural log. All right, x to the n. So we're just trying to come up with a generic here. when you do the antiderivative of x to a power, what would we have to do to the exponent? The derivative subtracts 1, so the antiderivative we would add 1. And if I want to cancel that exponent, what would I have to put in front?
1 over that.
1 over n plus 1. And then, of course, we have a plus c. All right, so the next slide is just a table of a lot of different antiderivatives. We know that when we did the derivative of a function, if it had a constant in front, we just kept the constant, so same thing works with antiderivatives. If it's multiplied by a constant, we can just keep that, it just trails along. If you have things added together, we knew that we could do the derivative piece by piece, so we can also do the antiderivative piece by piece. Now, a little bit different though when it comes to multiplication and division, because those, what did we have to do in order to do the derivative? We had to do product or quotient rules, right? So those we can't, if you have things multiplied together, we can't just do their antiderivatives. We're going to have some other things involved there. This is what we just came out with, x to a power, the natural log, e to the x, those types of things. So this is just kind of a summary of things that we might use. So let's practice finding some antiderivatives. All right. What I want you to do first is rewrite those, just like if we were going to do the derivative, we would get rid of the radical and write it as an exponent, so let's do that. So we have x cubed. How would I write 3 square root of x? Minus, how would I write 4 over x squared? So when I do my antiderivative, derivative subtracts 1, so we're going to add 1 to these powers. So 3 plus 1 is 4, so we have an x to the 4th. We have to put the reciprocal in front, so it's going to be multiplied by 1/4. Okay, here we have a 3. I'm just going to hang on to that for a minute. The x to the 1/2. If you add 1 to the power, 1/2 plus 1 is 3/2. What would I have to put in front? 2/3. I'm just going to hang on to this 4 for a minute. X to the negative 2. If I add 1, that's x to the negative 1. So what goes in front? And what do we need on the end? So if we simplify, 1/4 x to the 4th plus 2x to the 3/2 plus 4x to the negative 1 plus c. Is that one okay? I want you guys to try the next one. Write it to begin with.
X to the power 2 minus 5x to the negative 4 minus x to the 1.
So when I do my antiderivative, if I add 1 to the power, that would be 7/2. So we need a 2 7 in front. All right, you will probably get to the point where you can just go straight into the antiderivative here and not have to write this constant out, but for now I'm writing it just to show us what's happening. So if I add 1 to the power, negative 4 plus 1, negative 3, so it needs a negative 1/3 in front. X to the 1/2, 1/2 plus 1, is 3/2, so it gets 2/3, and we always have plus c. So 2/7 x to the 7/2 plus 5/3 x to the -3 minus 2/3 x to the 3/2 plus c. Is there any way to check our answers on these? Do the derivative. Okay, that's something we've done many, many times, and these are all pretty straightforward ones, so you can always check yourself. All right, let's look at the next one. All right, so if I'm thinking backwards, this 2 in front is just going to stay for a minute. What has a derivative of cosine? Sine. When you do the derivative of a trig function, does the angle change? No, so it's still sine of 3t. Now, I want you to walk through this though. If you do the derivative of sine, it would be cosine. Angle stays the same, but then what would you have to do? Derivative of the inside. We have to do chain rule in reverse. So the derivative of the inside is 3. What would I need to cancel that 3? 1/3. Does everyone understand where I got my 1/3 here? So this one I have a 5. What has a derivative of sine? Negative cosine. The derivative of cosine is negative sine, so we need negative cosine. When we do that, the angle stays the same. So if we think through this derivative of negative cosine would be positive sine, angle stays the same, times the derivative of the angle, which is 4, so we need a 1/4. And then always have a plus c. So we get 2/3 sine of 3t minus 5/4 cosine of 4t plus c. Why don't you guys see if you can figure out the next one? Remember, pi is just like any other number. So we have a 2. What has a derivative of cosine? Angle would stay the same, so what do we have to put in front? To undo the chain rule. Here we have a 3. What has a derivative of positive sine? Angle stays the same. Derivative of the angle is pi, so we need a 1/pi. And we have a plus c. So we have 2/pi sine of pi x minus 3/pi cosine of pi x plus c. Is that okay? Let's look at this one. All right. If it's things being multiplied or divided, we need to try to simplify first because we don't just have a rule for product or quotient rule in reverse. However, I don't really want to multiply x plus 5 10 times. The way this is written, if you were doing the derivative, you would do chain rule. So let's think chain rule in reverse. When we do the derivative, we subtract 1 from the power. So when we undo it, we would add 1. All right, when we do the derivative, the 11 will come down, so we need a 1/11 in front. Inside stays the same, subtract 1 from the power, times derivative of the inside. What's the derivative of the inside? 1. So do I need anything else to cancel it? No. If it were like a 2, I would need to multiply by a 1/2 as well. And then we just have our plus c. So we can do chain rule in reverse. All right. So for this one, how would I rewrite my problem to start with? So to undo it, the derivative subtracts 1, so the antiderivative would add 1. So it would be a -6. So what do I need in front?
Negative
So when you do the derivative, exponent comes down, that would cancel. Inside stays the same, subtract 1 from the power, times the derivative of the inside. Derivative of the inside is 3, so to cancel it, we need 1/3. So we get -1/18 times 3z plus 10 to the -6 plus c. How are we doing with these? Easier than what we have been doing? Hopefully. All right. Find all functions g such that g prime is equal to this. All right, I switched my notation a little bit. I'm saying this is g prime, so the antiderivative is just g. We have a 4 sine of x. Now, as this is written right now, it's a quotient. We can't do the quotient rule in reverse, but I could simplify this. 2x to the 5th over x.
2x.
Okay. The square root of x over x. That's like x to the 1/2 divided by x. If you are dividing, what do we do with the exponents? So 1/2 minus 1 would be -1/2. So just like derivatives, any simplifying you did before made your derivative easier. Definitely the case with antiderivatives. Okay, simplify first. So now, when I go backwards, that would just be function g. We have 4 times, what's the antiderivative of sine? Cosine. 2 times, what's the antiderivative of x to the 4th? All right, x to the -1/2. If I add 1 to the power, it would be a positive 1/2. So what would we put in front? 2 plus c. So -4 cosine x plus 2/5 x to the 5th minus 2x to the 1/2 plus c. Okay?
That plus c's gonna come back together.
Yep. That's where the -1/2 stack up.
Yeah.
All right, you guys try this one. Find function f if f prime is equal to this. Okay, so if we add 1 to the power, that's x to the 4th. So what do you have to have in front? 1/4. Can I go ahead and do 20 times 1/4? So we get a 5x to the 4th. All right, if I add 1 to this power, that's x cubed, so we need a 1/3 in front, so 12 times 1/3. Okay, if I add 1 to the power, that's x squared, so I need a 1/2 in front, 6 times 1/2. And then, and like we said, you can always check it just by working out the derivative. Okay, let's do this one. Find function f if f prime is equal to, this is a mess, e to the x plus 20 times 1 plus x squared to the -1. And f of 0 equals -2. All right. This one is not one that we can just work out using our power rules. So it's like that. I'm not sure. Another way of writing it is e to the x plus 20, 1 over 1 plus x squared. But I can't just say that was a natural log, because the derivative of a natural log is 1 over something, right? But if you did this derivative, the natural log of that would be 1 over 1 plus x squared. But when you did the chain rule, what's the derivative of the inside? 2x. And do I have a 2x up here? No. And I can't just say 1 over 2x, because if you have another x in there, that would turn into a product rule when you did the derivative. So it changes it. So since we can't use any of our other options, that means this is probably one of our special cases. So when we look back, I didn't put all of them on that table, so it could be one from the table. Let's look back at that. Is there anything that has a derivative of 1 over 1 plus x squared?
Wait. Yeah, the one.
If the derivative is 1 over 1 plus x squared, the original function was tangent inverse. Do you remember we did those inverse trig functions? I didn't make you memorize them, so that means I probably wouldn't put this one on the test either. I didn't make you memorize them the first time. I'm still not. My thought is they don't come up a whole lot. If you go into a career where you're required to learn these, then you'll learn those 6 things right then. But for now, I did give you this one, and I just wanted to show you a situation where that would pop up. Okay, so my antiderivative. What has a derivative of e to the x?
E to the x.
Plus 20. And what has a derivative of 1 over 1 plus x squared? Tangent inverse of x. Plus c. All right. Now, what I gave you is f of 0 equals -2. This is f of x. I am giving you the information to find out what c is here. I gave you an extra stipulation. So I know in this function, if I put in a 0, 0 plus 20, tangent inverse of 0, plus c, I have to get -2 for my answer. What is e to the 0 power? Tangent inverse of 0. That means find the angle when tangent is equal to 0. So think about our hand trick. Tangent's the square root of the top over square root of the bottom. So that's right here. What angle is this? 0. So tangent inverse of 0 is 0. So that means c is -3. So we found our constant. So our actual function is e to the x plus 20 tangent inverse of x -3. So if I give you a point on the original function, then you have the ability to find out what the constant is.
So what is tangent inverse?
It's finding the angle when tangent is equal to something.
Oh.
So if I said tangent inverse of x equals 0, that's saying tangent of 0 is equal to this.
Okay.
So it's working backwards. All right, any other questions? Let's do 1 or 2 more for today, and then we'll stop. This might be my last one today, I think. All right, find f if f double prime. What does that mean? The second derivative. Okay, so if I gave you the second derivative, that means we have to do the antiderivative twice. Okay, so when I work backwards from the first or second derivative, that would give me the first derivative. So if I add 1, that's x cubed. So we need a 1/3 in front. 1/3 times 12 is 4. Okay, 6x. So add 1, that's x squared. So we need a 1/2 in front. So 6 times 1/2 is 3. Minus, what would be the antiderivative of 4? 4x. And then what would we have to have on the end? Plus c. All right, did I give you a point on the first derivative? No, so I can't find my c yet. So now if I want the original function, we have to do the antiderivative again. So the derivative, or antiderivative of x cubed, if you add 1, that's x to the 4th. So we would need a 1/4 in front. What's 4 times 1/4? 1, so that's gone. Okay, x squared, if I add 1, that's x cubed, so I need a 1/3 in front. 3 times 1/3 is 1. Are you guys okay where I'm multiplying my constant with it? Okay. Minus, this would be x squared, so I need a 1/2 in front. 4 times 1/2? 2. Plus, what would be the antiderivative of c, just a constant? C times x. And then we would have a new constant, right? So I'm going to call it k. I don't want to say c again because they don't have to be the same number. All right. Let's see if we can figure out any of these. I know f of 0 is equal to 4. So if I put in a 0, I get 0 plus 0 minus 2 times 0 plus c times 0 plus k is equal to 4. So what's k? So now we can use the next point, f of 1. So if I put in a 1, 1 to the 4th is 1, 1 cubed is 1, minus 2 times 1, plus c times 1, plus k, but we already know k is 4, and we have to get 1 for our answer. So 2 minus 2, those cancel. So my c is negative 3. So my actual function is x to the 4th plus x cubed minus 2x squared minus 3x plus 4. Do we have any questions right now? So I'm going to stop here for today. There is a handout posted on Google Classroom. This handout will be due on Thursday. So tomorrow we will finish the notes. Technically, you could probably do 1 through 15 if you wanted. I would at least try to get 1 through 10 done for today.